Okay, so in section 3.2, we're looking at trigonometric integrals, and these are going to be integrals that involve sines, cosine, tangents, and secants. And as I told you, with trig functions, they have partners, okay? So sines and cosines are partners, tangents and secants are partners, and cotangents and cosecants are partners, okay? So that's just one way that you need to remember how they work together. So let me see here. I will draw, I think I'm gonna draw it in blue. And so I'm gonna draw a big box like this. And here's one line. And here's another line. Okay, so these are partnerships. So sine of X and cosine of X, they are partners. Tangent of X and secant of X, they are partners. Cotangent of X, cosecant of X, they are partners. Okay, so this is the partners. All right, so as you can see, we talked about integrating secant squared. Since it's a perfect derivative, that one was easy. Its integral is tangent. Cosecant, another perfect square with the perfect derivative with the exception of the negative, it comes back to be cotangent. Okay, so then we were using some of these trig formulas, which I hope you looked over. I told you the two that you absolutely had to remember, you need to actually remember all of them. So we're going to work on that today. So the first thing was, how do you integrate sine squared and cosine squared? So we did that last time. So now what we want to do today, starting with B, how do you integrate tangent squared and the integral of cotangent squared? And these are actually rather easy. The reason why they're easy is we just have to remember these formulas up here. All right, so that the tangent squared is 1 minus secant squared. So therefore I can just, tangent squared is secant squared minus 1, I apologize. Okay, so to integrate tangent squared.
Excuse me, Dr. Lott.
Yes.
A couple of students are saying that the link isn't working for them to join class. Mine wasn't working, but I had to like shut my computer off and do it again.
I have no idea why the link is not working. What? Okay, Rayshawn can't hear me. Eric's camera is still not working. So you're saying that they can't actually get on?
Yeah, because we have like a chat, so I asked them if their link was working, and a couple of students said not for them because I know mine wasn't working.
Okay, so hold on a minute. I can give me a second. Let's see. Okay, so I'm gonna send an announcement with the same link. I don't know. I just posted the link again. Okay, thanks, Qlay.
You're welcome.
Okay, so the integral of tangent of u du Well, we're going to take the tangent and write tangent as secant squared u minus 1 du. Okay, because remember we said tangent squared of u plus 1 is equal to secant squared of u, and the cotangent squared of u plus 1. Okay, we got to get that to shut up. Okay, so therefore, once I switch this over to secant squared, this is easy because the integral of secant squared is tangent, and the integral of 1 is just 1. So now we get that. So we get the integral of the tangent squared of u is equal to the tangent of u minus u plus a constant. Okay. All right, and the integral of the cotangent squared of u du. So that is equal to, well, we're going to trade off cotangent as cosecant squared minus 1 du. So this turns out to be minus cotangent of u plus a constant. So now we get the integral of the cotangent squared of u du is minus cotangent of u. Oh, that should be in minus u. I done switched it to a plus. Minus u plus a constant. Did I do that up there? Nope, it's still negative. Okay. Okay, so now we know how to integrate every function except secant and cosecant, and we know how to integrate every trig function squared. Okay, so the ones that you're going to remember, of course, are secant squared and secant squared and cosecant squared. For the cosine squared and sine squared, you're going to switch off to a formula. Same thing for tangent and cotangent. Okay, so now we know all of those. So let's just say we do a quick example. 2 quick examples. So one, let's try to find the integral of the sine of sine squared of 4x dx. Okay, so the integral of sine squared of 4x dx. So here u is equal to 4x du is equal to 4 dx. So dx is equal to 1 over 4 du. All right. Actually, I'm not even going to do that yet. Let's do the other part first. Let's split it. We know that sine squared of u is equal to 1/2 times 1 minus the cosine of 2u. So let's do that first. So let's make this the integral of 1/2 times 1 minus the cosine. And then instead of 4x, it will be 8x. Then I don't even have to do a u. Now it's nice and easy. So sine squared of 4x is 1/2 1 minus the cosine of 2 times 4x, which gives me 8x. So I can pull the 1/2 out. When I integrate 1, I just get x. And when I integrate cosine, I get the sine of 8x. But I have to divide by 8 So that gives me a plus. So therefore, this turns out to be 1/2 x minus 1/16, the sine of 8x plus a constant. Okay. Any questions about that? All right. Another way of writing it is to pull out the 16. Leave it. I don't feel like it. That's fine. That's fine. That's fine. Okay, the second example. The integral of the cotangent squared of 5x. Okay. Dx. So I know that cotangent squared of u is cosecant squared of u minus 1. So this then becomes the integral cosecant squared of 5x minus 1 dx. Okay. So this now integral of cosecant is minus cotangent of 5x, but it has to be divided by 5. Minus x plus a constant. Yes. Okay, any questions? Because it's getting ready to get hard. All right. So we know how to integrate all the trig functions squared. Okay, so now we want to get to what happens when we have products of sines and cosines. Okay, so now we want to do integrals of products of sines and cosines. Okay, so this is C. All right, so that means what I want to integrate is I want to integrate the integral of the sine of the sine of mx times the sine of nx times the cosine, I apologize, cosine to the n of x dx. All right, so this is what I want to integrate. So the first one I'm going to do is easy. So if I want to do the integral of the sine cubed of x cosine of x dx, this one is easy. And the reason why it is easy is because if I let u equal to the sine of x, its derivative du is sitting right next to it. So this is a perfect u substitution because here's du, cosine x dx, cosine x dx. That's easy. All right. So therefore, this integral just becomes u cubed, and the cosine x dx just becomes du. Now that is one of the easiest integrals ever. That is 1/4 u to the 4th plus a constant. So this turns out to be, sorry, mouse was in the way. This turns out to be 1/4, the sine to the 4th of x plus a constant. So the reason why this was so nice is because it had a derivative sit next to it. We can always integrate something, a function, if du is sitting next to it. So the first rule is that what we want to do is anytime we have two different cases. All right, so the first case, case 1, okay, and it is at least 1, could be both, of m or n is an odd positive integer. Okay, so this is one of the easiest ones to remember, is case 1, okay? And then the other one could be any real number it wants to be. We don't really care, but we care that we have at least m or n is an odd positive integer. Okay, so in that case, if you noticed here that the cosine of x, they both were odd, but I was able to pull off a cosine and let that be the derivative. So what we're going to be doing here is being able to identify the derivative, and then that helps us choose what u is going to be. Okay, so here's my example 2. And that is the integral of the sine cubed of x, cosine cubed of x, dx. Now, in this case, actually, let me just make one of them even. I'm gonna make one of them even. Okay, so as you can see, the cosine is even, but the sine is odd. So I have my odd power right here. So that's the most important thing, that one of m or n, the powers, is odd. If that is the case, we're going to peel one off, just one. So I'm going to write this as the integral of the sine squared of x, the cosine squared of x, the sine of x dx. So when I peel one off and leave that one there, then this now becomes my du. All right, so du now is the sine of x dx. So therefore, if that's the case, I want u to have been a cosine. And then I can fix my derivative to be negative like it's supposed to be. Okay, so I'm going to pull off the sine. So now I get the sine of x dx is simply negative du. So I'm able to get what I want. There's my sine of x dx. So by pulling off one of the odd powers, I can isolate that sine of x to be a derivative. Just one. But now if u is cosine, then that means this sine x has to be transformed, or it has to go. So this must go. Why does it have to go? Well, because this is going to be u squared. And this is going to be minus du. So this sine squared can't just be sitting there because it messes up my problem. But I do know that I can trade it off. So sine squared is 1 minus cosine squared of x. And then I still have cosine squared of x. And then I have the sine of x dx. So now it's perfect that this is going to be u squared This is u squared. And this is minus du. So I have everything taken care of. So now this becomes negative the integral of 1 minus u squared times u squared du. That's so easy to integrate. Okay, so I'm going to have, this is the integral now of u to the fourth minus u squared du. How did I get that? I took the negative, pushed it in, and then multiplied everything by u squared. Okay, I can integrate this. This now becomes 1 over 5 u to the fifth minus 1 over 3 u cubed plus a constant. But I know what u is. U was the cosine x. So this answer is 1 over 5, the cosine to the fifth of x, minus 1 over 3, the cosine cubed of x, plus a constant, and I am done. Okay, so whenever one of them is odd, peel off one to allow for it to be a derivative. Okay. Here's another example. The integral of the cosine to the fifth of 2x. Okay. All right. Here, there is no sine. It's just cosine, but it is cosine to the fifth and 5 is odd. So peel one off. Okay, again, one of them's odd, peel it off. So I have the integral, this is going to leave me cosine to the fourth of 2x times the cosine of 2x dx. So now this right here is what I'm going to have be du. So if that's the case, u has to be the sine of 2x. Now, obviously, when I take the derivative, I'm not going to get the cosine. I'm actually going to get a 2 times that. So now I can see that I'm going to get du is actually 2 times the cosine of 2x. So the cosine of 2x dx turns out to be 1/2 du. But there is my cosine of 2x dx. Now, the question is, this must go. So I have to make that, fix that by letting that be the integral of 1 minus the sine of 2x squared times the cosine of 2x dx. So the sine of 2x, remember, cosine squared of u plus sine squared of u is equal to 1. So if I have cosine squared of 2x, then I can trade it off as 1 minus sine squared of 2x. Anybody have a question? You guys look like, Monday, what is it? Monday morning quarterback.
I just have one question, Dr. Lott.
Yes.
While you were splitting off cosine 2x dx, how did you get the du again for 2 cosine 2x dx?
So when I pull off one, that one I'm going to use as a derivative. Okay, so I know that whatever my function was, the derivative had to have been the cosine of 2x. So that lets me know that I'm going to let my function be sine. And so now when I let my function be sine of 2x, I have to adjust my derivative because my derivative actually has a 2 that pops out from the chain rule. Then I can still solve for the cosine of 2x. So now this becomes the integral of 1 minus u squared. This should be squared. 1 minus u squared squared. Times, and this should be 1/2 du. Okay. So now this becomes 1 minus 2u squared plus u to the 4th. I can put the 1/2 out here, du. So now I can integrate 1/2. I'm going to get u minus 2/3 u cubed plus 1/5 u to the 5th plus a constant. And u is sine of 2x. So I get 1/2 the sine of 2x minus 2/3 the sine cubed of 2x plus 1/5 the sine to the 5th of 2x plus a constant. So anytime one of the powers is negative, pull it off. You start off right away with cosine to the 4th of x, sine to the 4th of x, sine of x dx. And you're going to work with that. So cosine is going to be u. So these are going to have to be traded. Okay. All right. Questions?
Wait, can you scroll up for a second?
I can. Where do you need me to go?
Just right there. Thank you.
Okay. All right. So the second case is the harder case. They're both even. Okay, this is the longer case. They're both even. All right, so here's an example. Sine squared of x times cosine squared of x dx. They are both even. Then we have to go back and use our rule that the sine squared of x is 1/2, 1 minus the cosine of 2x, and the cosine squared of x is 1/2 times 1 plus the cosine of 2x. Okay, so in here, sine squared, I'm going to get 1/2 times 1 minus the cosine of 2x. Then I'm going to get 1/2 1 plus the cosine of 2x dx. So if they're both even, you cannot pull anything off. You can only trade off for the double angle formula. One over 4, the integral, this is going to give me 1 minus the cosine squared of 2x inside. Okay. Whoa, I got another cosine squared. Okay, got to use another formula. Got to use the fact that cosine squared of 2x is 1/2 times 1 plus the cosine of 4x. Okay. So now I get 1 over 4, the integral of 1 minus 1/2 times 1 plus the cosine of 4x. That's what goes in there, dx. So this is 1 over 4, the integral. So I have 1 minus 1/2. So that's going to give me 1/2. And then I'm going to get minus 1/2 times the cosine of 4x dx. We can pull the 1/2 out, make this 1 over 8 and integrate. This is a 1, it becomes x. This is cosine 4x. It integrates the sine of 4x over 4 plus a constant. So I get 1 over 8x minus 1 over 32, the sine of 4x plus a constant. So whenever they're even, every time you get something squared, you got to keep trading it off. The integral cosine to the 4th of 3x dx. Okay, cosine squared of 3x is 1/2 times 1 plus the cosine of 6x. So this integral is the cosine squared of 3x squared dx. So therefore, I'm going to get that thing squared. So it's the integral of 1/2 times 1 plus the cosine of 6x squared dx. So I have to square that. So the 1/2 gets squared, so that becomes 1/4. Pull that out. Now I square this, so I get 1 plus 2 times the cosine of 6x plus the cosine squared of 6x. And oh my gosh, here we go again. I got another squared. So now I have to use that the cosine squared of 6x is 1/2 times 1 plus the cosine of 12x that has to go in here. Just like this had to go in there. So now I have 1/4, 1 plus 2 cosine of 6x, plus I have to put in here 1/2 plus 1/2 the cosine of 12x dx. So now I still have 1/4, but inside here I have 1/2 plus a half, so that gives me 3/2, 1 plus that, plus 2, the cosine of 6x, plus 1/2 the cosine of 12x dx. And I hope you see that I am using this rule over and over and over again. That is the integral of the cosine of kx dx is 1/k, the sine of kx plus c. And the integral of the sine, I haven't had to use this much, dx is -1/k, the cosine of kx plus c. I use that over and over again. So I'm getting ready to use it again right here. 1/4. 3/2 just becomes 3/2 x. I have plus 2. Then I have the cosine. This integrates to the sine of 6x/6. And I already have 1/2, and that's going to integrate to the sine of 12x/12 plus c. Three halves x plus 1/3 the sine of 6x plus 1/24 the sine of 12x plus a constant. Okay, any questions? Okay.
I'm
So
sorry,
that-
Dr. Luck.
Yes.
Before you continue, do we always like have to simplify? Just assuming if we have really large
I
numbers.
would actually write this as 3/8 x plus 1/12 the sine of 6x plus 1/96 the sine of 12x plus c. Either one is fine.
Because on the Trinity homework, I was kind of like, trying to figure out how the
Oh, they're gonna want it like
this-
that. Xfinity gonna want it like this.
they skipped a lot of steps. So I was like trying to figure out how they got
skipped
those
steps?
values. Yeah, they skipped a lot of steps. Well, for my homework when I was doing 3.1. But I was just wondering.
At the end, is it sine 2x or sine 12x?
That should be a 12. Ooh, that looks ugly. Okay. All right. So with sines and cosines, there are two basic rules. If everything is even, you got to trade off with the double angle formula. If anything is odd, you're going to pull off one of them and use it as the derivative, and everything else has to be in terms of the other function. Okay, any questions about that?
For the odd function, is it, do you always have to use either sine or cosine, or as long
No,
as
you
it's
have
a
to
neg-
use whichever one. Okay. So if I had the integral of the sine cubed of x cosine to the fourth of x dx, I'm going to trade a sign.
because it's odd, right?
Mm-hmm. I'm going to bring it out as the sine of x dx. And I'm automatically going to let u be cosine of 4x. And then I'm going to have to trade off this. This I'm going to have to trade. What am I going to do here?
You will trade cosine 7x dx, so it's going to be integral of sine 4x times the cosine of 6x dx
Mm-mm.
times,
Cosine of x dx.
oh yeah, cosine of x dx.
Okay,
Sorry.
so this is going to be my derivative. So u is going to be the sine of x. So now I'm going to have to trade off these.
Okay, thank you.
Okay, what do you do with that one?
Um, do we take off one from cosine 5 to the fifth x?
You could take off one from cosine because it's odd. You could take off one from sine because it's odd. You have a choice.
Or which one's easiest? Because
Okay,
do
the
we-
easiest one would be the cosine. Wait a minute, the easiest one would be the sine. The lower number is the easier one.
yeah, I'm gonna take that one because I think it was from the
The
rules that
easier
you gave
one-
us.
The easier one would be to trade off the one sine. That would be easier. And then if they're both even, then you got to go back to this hard stuff. Okay. Okay, so integrals of products of tangents and its partner is secant. Okay. Integral of tangent x. Well, we learned how to integrate this one a while back. We have to write this as the sine of x over the cosine of x dx. And we let u equal the cosine of x. And we let du equal minus the sine of x dx. So the sine of x dx became minus du. So therefore, this is the integral sine x dx. That's just minus du. And then the cosine of x. Well, that's just u. So this turns out to be minus the log of the absolute value of the cosine of x plus c. But Dr. Lott, you said tangents and secants are partners, okay? So we write this as the log of the cosine of x raised to the -1 power plus c. Not the cosine, not the inverse cosine, but the cosine raised to the -1 power. So I get the log of the absolute value of secant of x. So therefore, the integral of the tangent of x dx is the log of the absolute value of the secant of x. And unfortunately, that is all that we will be able to do today. We will have much more fun with this tomorrow.
Oh, Dr. Lott, before you end the session, I just wanted to get a quick note. If you might please scroll up on the examples we were doing.